Hey there. So today we are just going to continue working with functions. Now, more specifically, adding and subtracting functions. Now let's look at our essential question. How do you add and subtract polynomials with integer coefficients? Wait a minute. What do polynomials have to do with functions? Well, let's talk about it. So if we look at our first question, it says find f of x plus g of x. Okay, well, what's f of x? So we're given this information. It says let f of x equal 3x squared plus 4x plus 2, g of x equal 2x minus 3, and h of x equal negative 5x squared plus 3x minus 1. So we are given three different functions, and it wants us to find the sum of f of x and g of x. No big deal. Well, let's look. What's f of x? F of x is equivalent to 3x squared plus 4x plus 2. Hey, 3x squared plus 4x plus 2. That's a polynomial. All right, now we can see where we're kind of going to tie stuff in. So let f of x, so we're finding f of x plus g of x. So g of x is equal to 2x minus 3. So f of x plus g of x. So let's go ahead, plug it in, and simplify. So f of x we said is equivalent to 3x squared plus 4x plus 2. And we are going to add g of x. So I'm going to add 2x minus 3. I'm adding the whole thing, so I could put it in parentheses, but since I'm adding it, I don't have to. It's a preference thing. Okay, so when we add these, how do we add this? I have two polynomials, so how do I add two polynomials? Well, let's see if there's any like terms that we can actually combine. So I start off with 3x squared. Are there any other x squareds? I got an x. I got a constant, I got an x, I got a constant, so nope, I don't see any. So 3x squared, sorry dude, you're all by yourself. Now how about x's? I have positive 4x and a positive 2x, so I have positive 6x. All right, and then last but not least, let's look at our constants. Positive 2 and a negative 3, so positive 2 plus negative 3 gives me a negative 1. So f of x plus g of x equals 3x squared plus 6x minus 1. That's it. That's literally all you have to do. So we're applying principles that we've already learned, adding, subtracting, multiplying, a little bit of dividing polynomials, and we're just applying them to function notation. So nothing new here, it's just a different application. All right, so let's look at the next one. Simplify g of x minus h of x. Write our answer in standard form. Okay, so again, let's start off with g of x. So we have g of x, and it said minus h of x. Okay, so g of x, come back up here, 2x minus 3. And we are going to subtract h of x. So negative 5x squared plus 3x minus 1. Right now, how I have this written, it is wrong. There's something wrong. Remember, g of x minus h of x. So I am subtracting the whole function h of x. So to represent that, I need to have minus the whole function h of x. So I need to make sure I put h of x in parentheses, so to ensure that I subtract each term. Because if not, then we'll only subtract that first term and we'll forget about subtracting the rest. So when you're subtracting a function, make sure you subtract the whole. Parentheses are super important. Okay, so now all we have to do is simplify. So 2x minus 3 minus all of the h of x. So what are we going to do first? Well, when simplifying, let's start with that distributing. So I have, what am I going to distribute? A negative or a negative 1? So negative 1 times negative 5x, positive 5x squared. Negative 1 times positive 3x, negative 3x. And again, negative 1 times negative 1, positive 1. Okay, so we have 2x minus 3 plus 5x squared minus 3x plus 1. So let's find g of x minus h of x. All we have to do, simplify, combine like terms. Now we do like to write it in standard form, so I'm going to look at these and figure out which term, oh, there we go, we got an x squared, so that's the largest term, that should be our leading term. So I see a 5x squared, I don't see any other x squareds, so that I'm going to start with 5x squared. And then look at my x's, so I've got 2x and negative 3x, don't forget to include the sign. So 2x minus 3x gives me negative 1x or negative x, however you like to write it. And then let's look at our constants, a negative 3 and a positive 1. So negative 3 plus 1, negative 2. All right, I am in simplest form. So g of x minus h of x equals 5x squared minus 1x minus 2. That's it. Pretty cool? So we already know how to add and subtract polynomials. We're just applying it to function notation. So this is more of a reading problem than anything else. Reading and understanding the notation. All right, so let's look at this one. Find the missing side length if the perimeter is 18m cubed plus 2m squared minus m. Okay, so find the missing side length. So we're looking for the missing side length if the perimeter is 18m cubed plus 2m squared minus m. All right, let's talk about it. Perimeter. Oh yeah, that's the one we add. Okay, so the perimeter is the sum of all the sides. So we have side 1 and side 2. Hey, look at those. 5m cubed plus 3m squared minus 2m. These are the same. So just a little review. Remember, if you have two side lengths that are the same, you can annotate those with a little tick mark. Even though this may look like an equilateral triangle, we do not know if this is the same side length. We cannot assume. So we're going to find this missing side length. What do we want to call this? X? Since it's a missing side length, I don't want to call it m because I don't want it getting confused with my other variables. All right, so we know that the perimeter is the sum of all three sides. So I have two sides that are 5m cubed plus 3m squared minus 2m. I could have also, instead of multiplying them by 2, I could have added both the sides. I just didn't want to write all that. Plus our missing side x is equal to the perimeter. So let's come back over here. What was our perimeter? 18m cubed plus 2m squared minus m. Alrighty, so we are finding the perimeter. So right now I've set up a nice equation. All I have to do is solve. So looking at the left side, I don't see anything that I can simplify here. So I'm going to start on my right. First, I'm going to distribute this positive 2 to each of my terms. So 2 times 5m cubed, so I've got 10m cubed plus 6m squared minus 4m, and then don't forget our missing side, so plus x equals 18m cubed plus 2m squared minus m. Okay, so what are we solving for? because I got a bunch of stuff going on. Well, it's all about solving for x. We want to know what's the missing side. So I want to move over everything in blue over to my left side. So I'm going to just move things one at a time. So first, I'm going to cancel out this positive 10m cubed. So the inverse would be a negative 10m cubed. So I'm going to subtract 10m cubed using that subtraction property of equality. So we are left with 8m cubes. Okay, I'm just going to keep going. So then we've got a 6m squared, so it's positive, so I'm going to subtract 6m squared from both sides. Same thing, subtraction property of equality. So positive 2 minus 6 leaves me with negative 4m squareds. Okay, and then last one, that negative 4m. So opposite, positive 4m. So I use my addition property of equality. Now remember, this top one is a negative 1m. So negative 1m plus 4m, take away 1, I'm left with positive 3m's equals, hey, we're done, x. So our missing side length is 8m cubed minus 4m squared plus 3m. Awesome sauce. Great job. Pretty cool? All right. So our challenge problem says the polynomial 5v cubed minus 4v squared plus 10v minus 1 is subtracted from the polynomial 7v squared plus 2v cubed minus 7v. The difference can be expressed as av cubed plus bv squared plus cv plus d. Weird, but okay. So Rudy said that the value of a is 3. Is Rudy correct? I don't know. The only thing I can think to do is, well, do it. Let's simplify this. So this polynomial, this one right here, is, don't forget about the minus 1, is subtracted from, so we are taking it from the 7v squared. Okay, so then what do we start with? If this is subtracted from this, so I'm going to start with my 7v squared polynomial. And then I'm going to subtract my 5v cubed from it. Is that right? Are we ready to go? No, we are not. Remember, we are subtracting the whole polynomial, so you better put it in parentheses, or else you'll only subtract the first term. We've got 3 other terms we need to subtract. All right, so let's go ahead and distribute this negative. So I've got a negative 5v cubed. Negative 1 times negative 4, positive 4v squared. And negative 1 times a positive 10, negative 10v. And last but not least, negative 1 times negative 1, a positive 1. So we've got 7v squared plus 2v cubed minus 7v, and we are going to combine it with our new polynomial. All right, let's start off with like terms. So look, the difference can be expressed as, so this is just showing us, hey, they're putting the answer in standard form. So should we. So let's go ahead and start. What is the larger term? Well, it's all about the degree. So I think the highest is a 3. Yep, so let's go ahead and combine those. So positive 2v cubed, negative 5v cubed. Add those up, we get a negative 3v cubed. Then let's look at our squared. So 7v squared, positive 4v squared, 7, positive 11v squared, and our v's, negative 7v, negative 10v, so negative 17v, and then don't you forget about our little bitty positive 1 all by its lonesome at the end, so plus 1. Is that all we're doing? Are we just solving? let's come back up here. Rudy's, oh no, we're trying to justify, is Rudy correct or not? So Rudy said that the value of A is 3. Is Rudy correct? No, bud. A is definitely a -3. I'm thinking you forgot to subtract. Yeah, that's not good. Or maybe he subtracted this polynomial from this one. That would give us a +3. So, sorry, Rudy. Not correct. Rudy is wrong. Sorry, bud. So, hopefully that makes some sense. Let's go ahead, try some practice on your own. Come see me.